Here we have a series, an arithmetic series. So we're adding 1, 2, 3, so on, all the way up to 100. First of all, let's remember what we've learned so far. We learned about sigma notation. So why don't we write this in sigma notation? I'm going to pick a name for my index, so why don't I call it n? And we're starting at 1. And we're going to sum up to 100. So that's what it would look like in sigma notation. But sigma notation doesn't make the calculation of this any easier. We've written it more succinctly, but we haven't made it easier to solve. It's still going to take a long time to add up 100 terms. Gauss, being the smart, young, eventually to be mathematician, observed something about this series that allowed him to write it as an equation. So we want to write the above as an equation. I want to bring two facts to your attention. One, notice that 1 plus 100 is equal to 101. Now you might think, oh, well, what does that have to do with anything? Now I want you to notice that 2 plus 99 is equal to what? You guessed it. It's, well, you didn't guess it, you know. It's 101. What about 3 plus 98? It's also equal to 101. Isn't that interesting? Now, how are we going to use this? Now, notice that there are, well, we've got 1 plus 100. That's one pair. This is one pair. That's our, well, second pair. Maybe instead of one pair, we'll just say that's our first pair. Here's our third pair. Notice that we have, well, 100. This is big N. We have 100 divided by 2 equals 50 pairs of terms that sum to 101. And we can write this as an equation. The equation would therefore be, well, we've got 101 times 50. And the answer is 5,050. As our last procedure, let's generalize this. Let's generalize. And we're going to replace 100 equal to n. And when we do that, this equation right here, we're going to end up with the sum from starting from 1 and ending in capital N is going to be equal to n multiplied by n plus 1 divided by 2. Notice n over 2 are the number of pairs. What else can we notice from this? N plus 1 is equal to the value of each pair. So that was, for example, 100 plus 1, 99 plus 2, and so on. And so there is our Gaussian sum, a formula or an equation for a Gaussian sum. And I'm sure you already saw this, but I made it very silly Very silly mistake right here. Of course, 101 times 50 is equal to 5,050. Now we can derive a Gaussian sum equation a little more formally. So previously I gave you the intuition behind it. Now let's do it very formally, almost like a proof. And so I could write this in sigma notation just to sort of practice. Looks like, I think maybe I'll just change that to a capital N to be consistent. I'm going to rewrite this series S1 backwards. So I'm going to write it as n plus n minus 1 plus n minus 2 plus dot 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 plus 2 plus 1. So I said I would write it backwards. I'm writing it in reverse, right? And these two things are equal. So S1 is equal to S1. I haven't changed anything here. I haven't done any algebraic manipulation in any way. I've just redefined it, starting from the endpoint and counting down, which should give us the same value. Now, let's consider this. So I've got S1, 1 plus 2 plus 3 plus dot 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 plus n. I've got S1 is going to be equal to n plus n minus 1 plus n minus 2 plus dot 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 plus 1. Now let me add these two series together. So the left-hand side, I'm going to sum up the left-hand side and I'm going to sum up the right-hand side. Now the left-hand side is just going to be 2s1. Remember? Because they're the same thing. They're just written slightly differently. Here I've got 1 plus n. So I've got 1 plus n plus 2 plus n minus 1 plus 3 plus n minus 2 plus dot 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 all the way to n plus 1. Rewriting this expression, I've got 2s1 is equal to 1 plus n plus 1 plus n plus 1 plus n plus dot 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 plus n plus 1. And so now, what do I have here? Well, I have n numbers. I have n terms of 1 plus n, or n terms of n plus 1. And so I can rewrite this expression 2s1 is equal to n times n plus 1. I'll write it that way. Then if I solve for the series, I've got n plus 1 over 2. And there is my Gaussian summation equation. Like so.